Hi everyone, I am Bihan Chakraborty and today I'll be discussing LeetCode's problem number 80, that is remove duplicates from sorted array 2. So this is February 22's day 6 challenge and this is a medium level problem of LeetCode. So let's check it. So here we have been given an array nums that is sorted, okay, but it contains duplicates. So we have an array, let's see the examples and let me zoom in. Yeah, so we have an array that is sorted, that will always be sorted, and it has multiple elements. Okay, these have duplicates. So what we have to do is remove the duplicates in from the array. And but there's one catch. There can be at least two duplicates. Okay, so it was here, I think. Yeah, remove the duplicates in place, so we can't create a new array, or like we can't take any extra space. We have to do it in O of 1 space complexity, and each unique element appears at most twice, and the relative order of the elements should definitely be kept same. So basically the final result should also be sorted, and each element can appear at most twice. So check this example: 1 1 1, 2 2 and 3. So 3 is once, so that is fine. 2 is 2 times, so that is also fine. But this is the problem: 1 1 1, there should be at most 2. So we make the result like this: 1 1 1, so 1 1, 2 2 and 3, because we just have to remove 1. We don't need to remove all the ones. Okay, so this is the answer. So how do we approach it? Okay, let's check another example: 0 0 1 1 1 1, then 2, then 3 3. So we have to remove only these two ones, okay, because others are fine. So we do it here. And now another thing, since we can't like modify the arrays in all the languages, like in C we can't dynamically change the array, this given array, static array. So what we have to do is put all the elements from the start, and the last elements would be empty, or anything that can be anything that won't be checked actually. And we have to return the k, that is the size up till which my elements are there. So if we have removed one element from here, so the answer would be this array's length minus 1. If we had removed two elements from here, the answer would be this whole length minus 2. So I think you have got the idea about the problem. So let's check the code. Okay, so n is the total array's length, I is minus 1, and this is count, and this is k val. I'll come to it later, but this actually holds how many like repetitions can be there at most. So we have been given 2, so it is hard coded to 2. So you could just replace this k val with 2 here as well, here and here. Okay, so that's not the problem. So what is I and what is CNT? CNT basically is the count of how many duplicates are there. Now since this is sorted, we can directly check if my previous element was the same as the current, is the same as the current element. So we can simply do this: if arr j not equals to arr of j minus 1, that is I'm starting with a new element. If it is equal, that means both of them are equal, right? So initially we have 1 and we start from the second element of the array. Okay, so let me give this example. So initially count is 1, because of course one element is there, so we include it, and we start from the second element. Now we check if the previous element is the same as the current element. Okay, if that is same, we increment the counter, so it becomes 2 right now. So count is 2, that means there are two zeros here. Okay, now suppose I am here. Okay, so the previous element is not equal, so I make the counter 1 again, so there's just 1 present. Then we go here, so it becomes 2. Then we go here, it becomes 3. Now whenever it crosses 2, so this condition is triggered, and this condition triggers only once. Okay, because I is initially minus 1. Okay, so this is true always. And what is this? Count less than, sorry, count greater than k val. K val is 2, so count greater than 2. When does it occur? It occurs here, because we have 3 ones here, so count is 3. So this both are true. So now we make I equals to j. So we make I point to the current iterator, okay, the current index we are at. So I becomes j. So what is I? I is 3 now. Okay, so I is 3 here. Let me zoom some more. Oops. Yeah. So I is 3 here. After that, we move to the next element. We go here. We have counted 3. Now counter becomes 4. Okay. So we have another element. Now this condition will never be true again because I was minus 1. Then we increase it to something greater than 0. So whatever happens, this will always increase. So it can never be less than 0 because I equals to j and j starts from 1 till n. So this condition only occurs once. So this whole if will be like executed only once at the start, and once this is done, we have only this condition to check. We check whether count is less than 2, less than equals to 2, and I is greater than 0, because what this condition was doing is getting the first point from which repetition is starting. Because suppose I had initially 0 1 2 3 4 5 like that, then we won't replace those elements. Those are fine as it is and they are sorted already. So we will skip the elements and get the index from where this repetition is starting, because what we want to do here is remove, like not remove, we replace the elements with the other ones. Suppose I have two ones here, so we don't need the two ones. So what we can do, I can bring this 2 to this one, this 3 to this 2, and we can replace this 2 with this 3. Why? Now why are we replacing this 2? Because I have copied this 2 here. Okay, so I don't need 2 again, so this is extra, so we can replace it with this 3. So now what these two elements are again 3. So what does my final list look like? 0 0 1 1 2 3 3 and 3 3, but we return the index up till here. Okay, we return I in the end. So these two elements will never be checked. Why? Because if you check here, it is given that this is how the judge will check the solution. It will go till k is what we return here, and check if the expected answer is equals to the current answer. That is what it will check. It won't check anything after that. So whether that's -1, infinity, or like nothing, that doesn't matter. Okay, so like getting back to the problem. So yeah, this will be executed only once, and for this count is less than 2. So currently my count was 4, so this will not execute. So I'll move here 2. Now 2 is not equals to 1, so I'll reset the counter and becomes 1. Okay, so now I go here. Now count is 1, that is less than equals to 2, and I is also greater than 0. So what we do is copy ARR-J. ARR-J is 2. We copy it to ARR-I. So where was I? I was here. Okay, so I copy 2 to this 1. So 1 is removed and 2 gets here, and I increment the I. Now I goes here. Okay, I is now here. Now I move to my next element 3. So 3 is again not equals to 2 because this 2 is here. It's not deleted right now. So it is again 1. It is resetted. Counter is resetted to 1. So now this condition is again true, 1 less than equals to 2. So now we put 3, this 3 to this index. So 3 gets here, and I increment I to 0.2 here. So now I move j here at the last element, and 3 was equals to 3 and it was 1. So the counter becomes 2 now. 2 is less than equals to 2. So I copy this 3 to the current I. I had 2 element. So this is removed and it becomes 3, and we increment it here. Okay. Now k is here. Sorry, not k, I is here, and j is finished. So this loop is finished. Now after that, we just return I. Okay, so there's this condition, but like just ignore this condition for now. Suppose we are just returning I. Okay, so if we return I, which index do we return? We return this index. So if we return this index and the judge runs this condition 0, then I less than that index, then we are checking only these elements, right? So if we check only these elements, this is in the correct order. So we have repetitions here. What we can do is, right, again start from I till n and make all of them zeros, but we don't want that. We have been already given that, we have to ignore that. So we can just return this index. Okay, now why we are doing this? If I equals to -1, then we return n. That is because we are initializing it with -1, and in case this condition never triggers, that means count is always less than k val. That means there's no such element that has repeated more than k val. That is that has repeated more than 2 times. Okay, so there's no such element. That means that is already my answer. So we return n, the size of the original array. So that's it guys. So if you have liked my video, please like and subscribe to my channel, and if you have any query or doubt, please comment down below. And I'm creating the playlist of February 22's LeetCode challenge. So this is day 6, so I'll be uploading videos every day, so make sure to subscribe, and see you in the next video.